students, welcome to Aditya Study Academy. Today let us learn regarding arithmetic progression. Arithmetic progression is not a difficult chapter. It is a very easy and simple chapter where we have only a few formulas. Okay, let us start. Before going to the actual definition of arithmetic progression, let me give you some examples. Here I have taken one series of number. Okay, 3, 6, 9, 12 and 15. So here for 3 I have added some number, that is 3. So I have got 6. Okay. Again for 6 I have added 3. So I have got 9. For 9 I have added 3. I got 12. For 12 I have added 3. So I got 15. Means can you observe one thing? I am adding a 3 to each number. So I am getting a next number. This is nothing but an arithmetic progression. Means let me give you one more example. 10, 20, 30, 40 and so on. Here you can easily tell, right? If for 10 if I had 10, you'll get 20. For 20 if I had 10, you'll get 30. For 30 if I add 10, you'll get 40. Means the number which I'm adding is a fixed number. So I'm getting the next number. This series is nothing but an arithmetic progression. Means it is a list of number in which each term is obtained by adding a fixed term except this first term. Okay, this is what the arithmetic progression is. Now here I have taken one more example, that is a list of number. Okay, 4, 8, 12, 16 and 20 and so on. Okay, here I have taken a multiple of 4. So for 4 if I add 4 I am getting 8. For 8 if I add 4 I am getting 12. For 12 if I add 4 I am getting 16, and for 16 if I add 4 I am getting 20. Means the fixed number which I am adding is called as a common difference. Common difference. Okay, which is represented by D. And this is the first term, second term, third term, fourth term, fifth term. We will write it as A1, A2, A3, A4, A5 and so on. So the first term is always represented by the A. Okay, first term is represented by A and common difference is represented by D. And then how do we calculate the common difference? I've taken, let me explain you. Now first term is 4, second term is 8. Okay, common difference always will calculate by subtracting A2 minus A1 or A3 minus A2 or A4 minus A4 minus A3. Okay, let us see what we'll get by this. Okay, so here A1 is 4 and A2 is 8. Okay, so A2 minus A1, 8 minus 4. What we got? 4, correct? Next, A3 minus A2. What is A3? 12 minus A2, that is 8. 12 minus 8 is 4. And then next, A4 minus A3. A4 is 16. Then A3 is 12. 16 minus 12 is 4. Means in each calculation we got a common difference as 4. So actually means in arithmetic progression the common difference should be same. If we subtract second term by first term or third term by second term or fourth term by third term, then we need to get a same common difference. If we won't get a same common difference, then it is not an arithmetic progression. I have taken one more example, that is 1, 2, 3, 5 and 7. Okay, let us see if it is an AP or not. Okay, so for AP what it should be? Common difference should be same, right? The list of number to be an AP, common difference should be same. So let us check if this number is a AP or not. Okay. So for common difference, how do we find a common difference? D is equal to A2 minus A1, right? That is, what is A2? 2. What is A1? That is 1. So 2 minus 1 is 1. Next again, D is equal to A3 minus A2. What is A3? 3. And then what is A2? That is 2. So 3 minus 2 is 1. Okay. One more. Okay. D is equal to A4 minus A3. What is A4? 5. What is A3? 3. So 5 minus 3 is 2. See, here we got 1, here we got 1 and here we got 2. Means there is a difference in the common difference what we got. Right, that is 1, 1 and 2. So it is not an AP. Okay, the list of number which contain a common difference, same common difference, then only we can tell it as an AP. If we get a common difference different, okay, like different numbers, like 1 here I have got 2, then this list of number is not an AP. Okay, till now you got to know like which list of number will be an AP and which list of number will not be an AP. Means how? By calculate the common difference. If we get a common difference same, then that list of number is an AP. Where if we get a difference in the common difference, then that is not a AP. Right, now let us see the general form of AP. How do we write the general form of AP? It is written as A plus D, A plus 2D, A plus 3D, A plus 4D and so on. At last we'll get A plus n minus 1 into D. Okay, this is how we represent the general form of AP. Here A means A1, A plus D means second term, that is A2, A plus 2D means a third term, A plus 3D is a fourth term, A plus 4D is the fifth term, like this. A plus n minus 1 into D is nothing but a nth term. Next, in arithmetic progression, we have two types of arithmetic progression. That is, one is finite AP and other is infinite AP. You might be knowing what is finite and infinite, right? What is finite? What do you mean by finite? Then anything which can be countable, that is called as finite, right? And what is infinite? Anything which cannot be counted, that is infinite, right? Like that, in arithmetic progression also we have finite AP and infinite AP. Example, let me give you. Like in arithmetic progression, if we have a last number, then we will call it as a finite AP. Example, 2, 4, 6, 8, so on till 20. Here we have a last number. One more example, 10, 20, 30, 40, like that till 100. Okay, here we have a last number. So we can count this number, right? So it is a finite AP. Whereas a arithmetic progression which does not contain a countable numbers or a countable series of numbers, then it is called as an infinite AP. Example, 2, 4, 6, 8, so on. Means it continues. We don't know the last number. Okay, like that. 10, 20, 30, 40, so on. Here also we don't know the last number. If we have last number, then we can count that number, last term, right? Easily. So it will be called as finite AP. Whereas here we don't know the last number, so it is called as infinite AP. When nth term of an AP is given, then what is the formula we will use? That is an is equal to A plus n minus 1 into D. Okay, when we will use this formula, example I'll give you. Okay, in an AP, if they say in an AP, find the 15th term. Okay, and AP's list are like 2, 4, 6, 8 and so on, and the 15th term they have not given. So how do we calculate the 15th term? For that we will use the formula an is equal to a plus n minus 1 into d. Means here we have first term and we can find a common difference, right? Here n means nth term, okay. A means first term, whereas n is nth term and d is a common difference. So when they ask for to find the nth term of an AP, then we will use this formula, that is an is equal to a plus n minus 1 into d. Next, when sum of first year terms of an AP is given, then what is the formula that we use is S is equal to n by 2 into 2a plus n minus 1 into d. Okay, when we will use this formula to calculate the sum of first n terms of an AP, like example 2, 4, 6, 8, 10, so on till 20. Okay, so when this is given, this list of number is given, and if they ask like to find the sum of, means we need to find the sum of all this AP, like 10, so on plus 20. Okay, so at that time we will use the formula S is equal to n by 2 into 2a plus n minus 1 into d, where n is the nth term and a is the first term, whereas d is the common difference. And one more formula we have, that is S is equal to n by 2 into a plus L. What do you mean by this L? This L is nothing but the last term. What is the last term they have given? Then we'll substitute. We can use this equation, that is S is equal to n by 2 into a plus L. We have one more formula, that is S is equal to n by 2 into a plus an. When we will use this formula, when the nth term is given, then we can use this formula. Okay, these are the three formulas which we use to calculate the sum of first n terms of an AP. Okay.